Hi everybody and welcome to today's LEGO Technic video. So in my last video I presented this particular 2-speed automatic gearbox based on the powered up motor and app that you can see in the background, and the idea of this gearbox is that it will exploit the forward and reverse direction of the motor to change gears. So to understand that better, what I've got here is the internals of that particular gearbox, and what we've got is we've got this pivoting gear that will either connect to the left or connect to the right depending on the direction of the motor. So if the motor is going forwards, it would connect to the left and generate a certain speed at the output, and when the motor is reversed it will connect to the right and generate a lower gear. So that's the way of switching between a highest gear and low gear, simply by reversing the speed of the motor or the direction of the motor. And the way we detect the gear changing is simply by measuring the speed of the motor through the powered up app. So if the motor is experiencing a lot of torque, it will slow down, and then once it's slow enough we would switch gears to the right by reversing the direction of the motor. Now the big drawback of this particular gearbox, even though it worked very well, was it can only go in one direction. So because we're exploiting the forward and reverse mechanism of the motor, rotation of the motor, the output's always going in one direction in two different speeds. So to address that particular problem, I've come up with a new design for a gearbox using two motors, exploiting that same idea, and allows me to create a 2-speed automatic gearbox going both in the forward and reverse direction. So if that's something you'd like to hear more about, please keep watching. Alright, so the design of this particular gearbox, instead of having just one motor, I've now got two motors, and now of course that's required to be able to generate all the four combinations that are required, so both forward and reverse in both low and high gear. And again, each motor in this case has got this pivot gear that will change with the direction of the motor. So for example, motor A on the left, if I put that in the forward direction, it will connect to the center. And the center is connected pretty much directly to the output, so that will generate the forward high gear. If I then reverse that motor, it will connect to the left, and that will connect through this lower gearing mechanism, and also reverse the direction of the output, so that's going to be the low gear reverse. And then same with motor B, what we have to make sure of course is that motor A is disconnected by moving back into the middle. Then when motor B connects, again it connects to the center and create a high gear in reverse or generate a low gear forward. So we've kind of got four different combinations, and those four combinations are controlled through the programming that I'll tell you a bit about later in the latest segment of this video. So that is essentially how I generate the four different combinations, and I've drawn in the back here a state diagram. So the state diagram has got the four different states. So we've got forward and high gear, then switching to reverse and high gear, so that's done manually. So if we want to go between forward and reverse, we've got a manual button. And then when we're in, for example, the forward mode, we've got an automatic mechanism to go from the high gear to the low gear. The same with reverse, we've got an automatic reversal in reverse, an automatic mechanism to go between high gear and low gear and back again, so that's the switching. And if we're in low gear and we do a manual switch to from forward to reverse, it'll kind of go back to high gear, and then if required it will automatically switch back to low gear if the torque is high enough on the motor output. Okay, just to explain another important part of the gearbox design, and that is, like I explained before, only one motor is going at a time, and when one is going the other one has to be disconnected from the gearing mechanism, and the way it's disconnected is by moving that pivot back to the center. Now, in order to move it back to the center, what I do is, say once it's connected to the right, for example, I will reverse the motor for that particular gear, and that will push it back in the reverse direction, but there's a risk that it'll go too far and connect to the other side. So what I've done, I've got these rubber pieces just to help to act as a barrier from going too far, and also allows it to push off from that rubber in order to go in that opposite direction. So from a programming point of view, what I've done is simply reverse the direction of the particular motor that I need to do that for, and I rotate it about 70 degrees in terms of the axle angle, and that's enough to make that pivot go back in the opposite direction and disconnect from the gearing mechanism, and that will allow me to, for example, then turn on the other motor and reconnect it. And then of course once that one is needs to change, I then do the same thing and move that other pivot back to the center using the same technique. And that will allow me to switch gears smoothly without any gearing conflicts. So I'll just demonstrate how that works in practice. So what I've done here, I've created two buttons programmatically that will turn on that one of the motors, and then for 2 seconds and automatically switch that pivot back to the center. So I'll just demonstrate that with the blue button. That's motor A, that will turn on, and as you can see the pivot moves first to the right, and then once it's been running for 2 seconds it moves back to the center. So let's demonstrate that again. So it connects to the right, turns the output, and then moves back to the center. Same with motor B. I can push that to the right, and then it moves back to the center. So that allows me to, like I said, move the pivots from being activated to being disconnected, and to prevent any conflicts within the gearbox. Alright, I'll just explain some of the coding behind the scenes in order to make this gearbox work and switch gears automatically. And now what's really helped me with the programming is the state diagram over here. So like I talked about before, we've got the forward states and the reverse states. We've got a high gear and a low gear, and in the reverse we've got the high gear and low gear. We switch between high and low automatically, and between for the forward and the reverse, and we switch between forward and reverse manually using a manual button. So obviously if you're driving a vehicle or something like that, you want to manually switch between forward and reverse, but automatically between high gear and low gear. So each of these different states correspond to different directions of each of the motors. So for example, going forward in high gear, motor A is positive, we're going in the forward direction. For forward low gear, B is going in the positive direction and A will be off. And vice versa for reverse high gear, B is going the reverse direction, which means it's a negative speed, and same with reverse low gear, A will be in the negative speed. So it's kind of like forward is either motor going forwards, and reverse is either motor going in reverse. So in terms of the coding, so I've got I guess 2 large code blocks that are pretty similar. The top one is for the controlling the forward automatic switching, and the bottom one is controlling the reverse automatic switching. So they're pretty much the same, except of course with different parameters corresponding to the different motors. And I've also got the special purple code block here that I've created, which is kind of like a subroutine, and that subroutine is the one that switches the pivot gear back to the center. So I demonstrated before that pivot, and it has to be moved back to the center in order to disconnect the motors, and that's pretty much done in that purple subroutine. It's pretty much a couple of logic blocks to work out what state we're in, and then from that state it'll automatically move that pivot back to the center using the corresponding motor and direction. So coming back to the main logic block, so what we've got is our button here, which tells the system's going to the forward mode. We then test if we're forward already or not. If we are already in the forward direction, it just kind of ignores the button. But if we're not in the forward direction, we must be in the reverse direction. In that case, it'll stop the other code block, and it will move one of the pivots back to the center. So it's turn the gearbox back into neutral, if you like, and then it will switch to a state A is going at speed 100, which is the forward direction state. Wait half a second for that speed up, and then it kind of goes into this testing loop that will test whether or not we need to switch gears from high to low automatically. So what we do there, we first of all test whether or not we are in the high gear state by looking at whether or not A is greater than 0. And if it is, and at the same time A is less than 60, which means there's a lot of torque being experienced, normally the speed can go up to about 120, that means we need to switch gears. So if that is the case, what we do, we switch the pivots back to the center, and we put motor B in the forward direction. So B is 100, and that will put us into the forward low gear. Then the loop kind of repeats. So if we don't need to switch gears from high to low, then we test if we need to switch from low to high by doing the opposite test, by checking whether or not B is getting particularly high. So that means there's not a lot of torque on the motor. So if B is high enough, then we pretty much put the pivots back to the center and put A back into the forward direction at the high speed, at the high gear, which is A is 100, and we wait half a second and repeat the loop. So that's pretty much the mechanism for the automatic switching between the high gear and the low gear. Like I said, it's a very similar code block for the reverse gears. And so yeah, so that's pretty much how the gear switching works in the code blocks. Alright, so now you understand how the code block works. I'll just give you a demonstration of the gearbox in practice. We'll just move to the UI mode. So here are my two buttons, yellow and green. That's my forward and reverse directions for the gearbox. So we'll put it into forward, and look at that, we are now in the forward high gear, and as soon as I put some loading on that gearbox, it will switch automatically to the low gear. Look at that, and then once I let go, it switches straight away back into high gear. So I can demonstrate it again, put enough torque on it, switches to low gear, let go, switches back to high gear, and if I put the gearbox in reverse, of course it'll reverse direction, and again if I put that loading on that reverse direction, it'll switch down to the low gear, and then once I let go, switches back to the high gear. So there we have it. That is the automatic gearbox. It works really well. Now there is a small downside, as there always is to pretty much every design that you end up coming up with, and of course that is the rubber pivots. They do add a bit of drag to the motor, to the overall mechanism, but that is offset again by the fact that we've got a very short distance between the motor and the output in terms of number of gears. Normally with gearboxes you have to go through some sort of other switching mechanism, which also adds quite a bit of friction and loss of torque. So yeah, it's either one or the other, but this is a fairly compact design. So please like and subscribe if you did enjoy this video. Hope to see you next time. Thanks for watching. See you later. Bye.